let's look at how to help with assignment work. Now, you need to find out what is the fastest possible route for a flying bot to reach boats in distress, a boat in distress. So, looking at how long it might take to actually travel between two locations and which route might be the best possible to choose from. So you'll notice on this map you've got two locations. A is 30 degrees north, 100 degrees east, and B is 12 degrees south, 130 degrees east. Step 1 is to find out which route should be taken if you can only travel over lines of latitude and longitude. Now keep in mind, lines of latitude and longitude don't necessarily have to be shown with these with print. Okay, it can travel in between these sections as well. Now, let's start by going from A to B by travelling through lines of latitude here, turning at this location to travel down to B. We'll call this route 1. Now, looking at route 1, we have to find out how many kilometres from A to this location here. Okay, now let's start by finding the angular distance. A is situated at 100 degrees east, and we need to travel to this location here, which will be in line with B, which is at 130 degrees east. So we know that the angular distance from 100 to 130 is 30 degrees. 1 degree, when dealing with lines of latitude going horizontally, is equal to 111.2 cos, and this here is looking at what is the degree of line of latitude. Now, if we have 30, then we need to times this here by 30. So the line of latitude that they both lie on is 30 degrees. So we will have 30 degrees times 111.2 cos of the angle 30. Now putting that in your calculator, that should allow you to have the number of kilometres 514.58. Okay, kilometres. So that is how far you've travelled from A to this spot here when you'll actually start travelling down. Let's find out how many kilometres it is from this spot here down to location B. Now, line of longitude, that is going vertically. Under longitude, a reminder that 1 degree is equal to 111.2 kilometres. Okay, there's no trig ratio involved here. So how many angular degrees from here to here? Now, you'll notice that this lies on 30 degrees north. You have to travel down to the equator, so that's 30 degrees here. Plus, to get from the equator to B, which is at 12 degrees south, you've got 12 degrees here. 30 degrees plus 12 degrees, you need to travel 42 degrees. So 42 degrees, angular degrees, each degree equals 111.2, so 42 degrees. We've got 42 lots of 111.2 kilometres. We are travelling 4,670.4 kilometres. Okay, so route 1 has 514.58 kilometres from A to this spot here, and 4,670.4 kilometres from this turning point down to B. Let's add those together to get a total. Route 1 requires 5,184.98 kilometres. Okay, now we should also look at route 2. You might want to travel down this line of longitude first to a turning point in order to travel along a line of latitude horizontally through to B. Okay, so let's just work out what the distance would be for this route. We'll call it number 2. Let's start with this line of longitude here. Remember, 1 degree of longitude is equal to 111.2 kilometres. How many angular degrees do we have? It starts at 30 degrees north, travel down to the equator, which is 0. From 30 down to 0, that's 30 degrees. We have to travel an extra 12 degrees. You'll notice that B lays on 12 degrees south. That's where this spot here is. So another 12 degrees, 30 plus 12, that is 42 degrees to travel from A to the turning point. If we have 42 lots of 111.2 kilometres, then we are travelling a total of 4,670.4 kilometres. Okay, you'll notice it's the same as what we've worked out before here. Okay, because lines of longitude doesn't matter which one you're on, 1 degree always equals 111.2 kilometres. Now let's work out, this is the most important part, from the turning point to B, this is a different line of latitude than before. Now it is closer to the equator, which means it's actually going to be a wider circumference than if you were over at 30 degrees north. So let's work out this line of latitude here. The angular distance, how many degrees do you have to travel from the turning point to B? Remember, we started here. Now, A was located on 100 degrees east, and you're traveling to 130 degrees east. So that's 30 degrees you've had to travel from the turning point to B. So we've got 30 lots of, now we remember that for lines of latitude, it is 111.2 times cos, and the cos is of the line of latitude that both locations lie on. Okay, if we travel back to here, remember that it was at 12 degrees south. So we're on a line of latitude of 12 degrees south. We'll put 12 degrees. Let's put that into the calculator to see how many kilometres are travelled from this turning point to B here. All right, so 3,815 kilometres are travelled from this point here to over here. Now, you'll notice it is closer to the equator, so it is further to actually travel. Before, it was only 514.38 kilometres when on 30 degrees north line of latitude, okay, because it's a smaller circle. So I'm not going to bother finding out how far this will be because I know that this is shorter. So let's just choose the shorter route. All right, next step. You'll notice when dealing with navigation, often nautical miles are used instead of kilometres. Okay, so a really important thing to remember is how to go from 1 kilometre and convert it to a nautical mile. Now, 1 kilometre is equal to 0.539957 nautical miles. So, as before, we worked out that we had 5,184.98 kilometres. To go to nautical miles, we simply multiply by what 1 kilometre is equal to. So that's 0.539957. This is to go from kilometres to nautical miles. If we pop that in our calculator, we'll find that 5,184.98 kilometres equals 2,799.67 nautical miles. Okay, and because nautical miles, they will be regularly used when dealing with navigation, especially in oceans. Okay, now, this triangle here shows the relationship between speed, distance, and time. You should be familiar with this triangle system by now. We know that speed is equal to distance over time, or distance divided by time. If we want to know what distance is, distance equals speed multiplied by time. If we want to know what time is equal to, time is distance over or divided by speed. Now, say if we're asked for time specifically, you want to know how long is it going to take you to travel from one spot to another when traveling at a particular speed. Now, distance in this situation will always be in nautical miles. Time will be dealing in hours. And speed will be looking at knots. And knots is how many nautical miles you travel in 1 hour. Okay, so say we are traveling at 60 knots. Okay, the flying boat might travel at 60 knots. We've just worked out how many nautical miles need to be travelled. We might be asked for how long should that take us. Let's rearrange this triangle or use this triangle to create a formula for time. Time is equal to distance over speed. Now the distance we've worked out is 2,799.67 nautical miles, and the speed that the flying bot will be travelling at is 60 knots. Let's work out the time taken for this flying bot to undertake this travel, 46.66 hours is what this calculation equals. If I could say in this video, we have to part 2, post part 1, 2, as well as part 3. Now, part 4 is asking about what's the total cost of the rescue. Okay, so say if it was to cost $100 an hour and the flying bot took 46.66 hours to get to a location, okay, you would need to multiply $100 times by 46.66 hours. That would allow for the total cost to be $4,666. Now you'll notice in your assignment, the flying bot does in fact cost $125 an hour. Okay, so this is just an example. It does also say that the route has to be both from the flying bot's base to the boat and then back to the base again. So you might need to double the distance from the initial spot through to the boat as it's got to travel back again. And looking at part 4, it does say 30 minutes is spent at the boat taking photos before returning. Okay, it's not going to arrive at the distress boat and leave immediately, so you need to add half an hour onto your total time, 30 minutes. All right, good luck with task 1 and 2 of your assignment. And remember that this Friday, task 1 and 2 will be collected as drafts. Do the best that you possibly can and email me for any assistance. Thank you.